These are fine, na?
Yes.
Good morning. Good morning to everyone. So all of you are there? Hmm? Good morning. Good morning, still there. ಬೆಳಗಿನ ಶುಭೋದಯ. Welcome. Yes. So good morning. So shall I start with the class? So good morning. Good morning to everyone. So yes sir. Done. So before starting with the class, as usual, I'll be refreshing whatever we have discussed in the last class, right? So what and all we had discussed? We have discussed about adsorption. So we had discussed about the adsorption. Then we have discussed about absorption. And I told these two can be discussed under one title, which is called as sorption. Right? So that's where adsorption, absorption and sorption. Right? So these are the three important words which we have discussed in the last class. Then we have discussed about desorption. Then we have discussed about the desorption. And I told adsorption and desorption, they are opposite to each other. Right? So that's where we have the adsorption, which is a surface phenomena, and absorption, where throughout the molecule or component interaction will be happening. So it is only on the surface interaction will be happening, and together it is called as sorption. That is, sorption is nothing but it's a physical or chemical interaction between the interaction in the sense attachment with respect to two components with each other, right? So then we have discussed about desorption. Now desorption is opposite to that of the adsorption. Yes, Manjushri. Then Purnima. So whatever people have told is correct. Adsorbate, adsorbent. Even we have discussed about adsorbate and adsorbent. So adsorbate means these are the molecules which is getting adsorbed on the surface. Adsorbent is the material or molecules on the surface of which adsorption is taking place, right? So that's where we have the adsorbate and adsorbent. Then what else we have discussed? Yes, types of adsorption. In types of adsorption, what we have discussed? We have discussed majorly about Physisorption, but still we have to discuss about chemisorption, right? So that's what we were discussing about. Physisorption already we have discussed, but still we have to discuss about the chemisorption, right? Now, when it comes to physisorption, can anyone tell me, with respect to thermodynamic principle, what is the change in enthalpy and what is the change in entropy during the adsorption? What is that change? That is, in both the cases, with respect to entropy also, there will be decrease in the entropy, and with respect to enthalpy also, there will be decrease in the enthalpy, right? So that's what we have discussed in the last class. This is related to thermodynamic principle. So that's where we have decrease in the entropy and decrease in the enthalpy. Now when it comes to physisorption, all of us we know that since adsorption is a exothermic process, since it is a spontaneous process, adsorption is a spontaneous process. So in that case, there will be liberation of heat. There will be liberation of heat. So when it comes to physisorption, enthalpy of physisorption is somewhere around 20 to 40 kilojoules per mole, right? So with respect to physisorption, it is 20 to 40 kilojoules per mole. So that many amount of energy will be released whenever physisorption will take place, right? So now along with that, there is a non-specificity or least specificity. There is a non-specificity with respect to physisorption. There is a non-specificity with respect to physisorption. Ravikant, it is not 240, 240. Okay, na? So not 240. So it is 20 to 40. So that is the amount of energy which will be released. Now it is non-specific in nature. Physisorption is non-specific in nature. Fine. So all of you have understood. Now we will move to the next one. Another very important concept which I had told, that is related to chemisorption. Okay, na? So what we are going to discuss now here is chemisorption. Now when it comes to chemisorption, in the name itself it is there. There will be a formation of chemical bond. There will be formation of chemical bond, or there will be chemical interaction between the adsorbate and adsorbent. Now when it comes to specificity, now Devraj, I don't know what is that name, Devraj Shetty, okay na? So question here is, what is meant by specificity? Specificity means whenever there is a bonding will be there. See, for example, if I take water, specificity is in such a way that each hydrogen has been bonded to oxygen. Hydrogen, they are not bonded to each other. It is hydrogen to oxygen, hydrogen to oxygen. So that's where there is a specificity. Specific interaction is taking place. Okay, specific bonding has taken place. That's why water molecule is existing. Right? So we cannot write the water molecule as HHO. Whether we can write like this? No. So that's where we have the specificity with respect to bonding. So that's what with respect to specificity here also. So they are having less specific because there is no particular bonding which is happening. Fine? Whether I am clear? Have you understood there, right? So now we will move to the chemisorption. Now when it comes to chemisorption, I can tell that there is a strong interaction. There is a strong interaction between. There is a strong interaction between adsorbent and adsorbate. There is a strong interaction between adsorbent and adsorbate. So right now, due to presence of strong interaction, they are having specificity. Specificity with respect to interaction. Fine. Yes, they will form unimolecular layer. Anyway, we'll keep it easy only. So they will form unimolecular layer. But before that, they have this strong interaction between adsorbent and adsorbate, and they are having specificity. Now, since there is a strong interaction, since there is a new bond formation which will be taking place, so therefore enthalpy of the process which is that process? That process is chemisorption. Enthalpy of the process is pretty high, so which can range up to 200 kilojoules per mole, which can go up to 200 kilojoules per mole. Pretty high energy is released. When it comes to Physisorption, very low amount, but here 2200 kilojoules per mole, up to that enthalpy is present during the chemisorption. That's where they differ from the Physisorption, right? Now, if you have understood these things, now I can tell, or now I can write which are those differences between chemisorption and Physisorption. First I will write the difference. Now, when it comes to difference, Physisorption and chemisorption. If I want to talk about the difference, first one here is there is low energy involved in the process, or low amount of interaction. I will use the word interaction only. There is involvement of low interaction, where low interaction between adsorbate and adsorbent. All of you can see the board, right? Adsorbate and adsorbent. Here it will be high amount of interaction. Here it is high amount of interaction. Right? Now here it is majorly physical interaction dominates. That's why it is weak. But here chemical interaction dominates. Where in case of the chemisorption. Right? Now, when it comes to Physisorption, non-specificity is there, or I can tell low specificity. Non-specificity or low specificity. But here specificity is present. Next, what and all? Next, here enthalpy of the process. Is nearly 20 to 40 kilojoules per mole, right? But here enthalpy of the process here is Enthalpy of the process, that is amount of energy which will be released. It will be, enthalpy of the process will be, it can go up to 200 or even 240 or 250 kilojoules per mole, right? So that's where we have the enthalpy of the process, energy involved in the process. Next, when it comes to Physisorption, as you increase the temperature, very important, as you increase the temperature, Physisorption will be lost. There will be no Physisorption. That means, as increase in the temperature, no Physisorption, and increase in the temperature, no Physisorption. But exactly opposite for chemisorption. Increase in the temperature favors chemisorption. Increase in the temperature favors chemisorption, because new bonding will be formed, right? So therefore it will favors the chemisorption. That one, increase in the temperature. Therefore, Physisorption is reversible. It can be easily reversible. But when it comes to chemisorption, it is irreversible. It is irreversible. Or someone has already written, Ravikant. Yes, when it comes to Physisorption, it is reversible. But when it comes to chemisorption, it is irreversible. That's where activation energy. So Manvik, that's where I am talking about here. Increase in the temperature favors chemisorption. That means it demands high activation energy. That is the reason. Here it will be low activation energy. Therefore, if you increase the temperature, there will be not be any Physisorption. Okay? So that's what we have included here. So that's where we have the Physisorption and chemisorption. Now when it comes to Physisorption, another very important point here is those type of molecules which are having high critical temperature. Those type of molecule, that means I am talking about adsorbate. So those type of gaseous molecules which are having high critical temperature, they can go with the Physisorption mode. Whether I am clear, I will tell. Nature of the adsorbate is going to have high amount of impact. Nature of the adsorbate has high influence, on the Physisorption, have high influence on the Physisorption. On Physisorption. All of you can see, right? Handwriting, all of you can understand? So, nature of the adsorbate has high influence on the Physisorption compared to chemisorption. Chemisorption is having less influence of the nature of the adsorbate. That is another difference. All of you have understood? Now, low amount of interaction and high amount of interaction between adsorbate and adsorbent. That is very important. Now, physical interaction is going to dominate, like van der Waals interaction and all, which is going to dominate. But when it comes to here, there will be presence of chemical interaction, bonding. Now here, due to low interaction, they have low specificity. Here, specificity is more with respect to chemisorption. Now, enthalpy of the process is 20 to 40 kilojoules per mole. Here, it can go up to 250 kilojoules per mole with respect to chemisorption. So, high temperature will decrease the Physisorption. High temperature will favors the chemisorption. And now, Physisorption is reversible and chemisorption is irreversible. All of you have understood? So, these are the major difference. Now, something I was telling here. Now, please remember, this is very important for your board exam. These are important concepts with respect to your board exam, no doubt. Now, last point I will further explain briefly, where I have written nature of the adsorbate has high influence on the physisorption. I have written. What is that nature of the adsorbate? But these points are clear. Rest of the points, shall I go with what is that nature of the adsorbate? So now, when it comes to nature of the adsorbate, if I consider I am talking about the gaseous molecules getting adsorbed on the surface of the solid surface, if that is the case, easily liquefiable gases, they can easily go for adsorption, that is physisorption. They can easily undergo for physisorption or adsorption. Easily show physisorption. So that is the point here. Easily liquefiable gases. Now, easily liquefiable gases will have naturally high critical temperature. They will be having high critical temperature. Now, in states of matter, already people have discussed. What do you mean by critical temperature? Anyone? What do you mean by critical temperature?
Temperature above which the gas cannot be converted into a liquid.
Very good. So it is the temperature at which gas above or at this temperature a gas molecule cannot be converted into a liquid. So naturally easily liquefiable gas should have high critical temperature, right? So that's where they can easily undergo for physisorption. Remember this point, okay? So in competitive exam it may help you out. So that's one point which we have wanted to discuss here. Now one of the point is that which is common for both, which is commonly applicable for chemisorption also, physisorption also, that is surface area. That is nothing but surface area, right? Now when I am talking about surface area, as there is an increase in surface area, it's going to increase the physisorption. And even chemisorption. Therefore, this is the common point with respect to chemisorption and physisorption. There is no difference. So increase in the surface area will enhance the adsorption process. That one I am going to explain whenever I will be talking about heterogeneous catalyst. Okay? So you should remember that one. Now Manjushri, she has written physisorption is multimolecular, chemisorption is unimolecular. Yes, because there is a physical interaction in physisorption and in chemisorption it is chemical interaction. Therefore, in physisorption is multimolecular normally and in chemisorption it will be unimolecular. Fine. So that's where we have the surface area. Increase in the surface area will increase the physisorption and it will increase the chemisorption also. Fine. That's where we have discussed about physisorption and chemisorption. All of you have understood. Now, if I want to give the example, for physisorption, the example can be where inert gases getting adsorbed to metal surface. Inert gases getting adsorbed to metal surface. That can be the example for physisorption. Okay? So when it comes to chemisorption, lots of examples. Like we are using hydrogenation process where hydrogen gas will be used along with the palladium as the catalyst, right? Or hydrogen gas will be used along with the nickel as the catalyst. So whatever I am talking here is, this was related to example for physisorption. This is related to example for chemisorption. Now when I am talking about hydrogenation process, these are the conditions which will be normally utilized. Or in case of the Haber's process where iron oxide will be used, where iron oxide will be used, which I am going to explain, don't worry. In P block also we are going to discuss this one, and here also in heterogeneous catalysis I am going to explain this one. So what I mean to tell here is, in Haber's process also we are using hydrogen and nitrogen gas. So there also there will be interaction between these gaseous molecules with the metal. Okay, metal oxide here, here it is metal. They are all example for chemisorption. They are all examples for chemisorption. Fine. So if you want to take the example, these are some of the examples for physisorption and chemisorption. Okay. Now I will move to the next one. That is quite important with respect to our board. Whatever I will be discussing now, bit important with respect to our board or with respect to our competitive exams. It is bit important. That is Freundlich. That is nothing but Freundlich adsorption. Freundlich adsorption isotherm. So I will mention this one as important. Not very and all. I have mentioned just as important. Freundlich adsorption isotherm. Okay na? Now when it comes to Freundlich adsorption isotherm, in the name itself it is that it talks about the relation between the adsorption process at a constant temperature. First I will clear it. This is nothing but a person's name. A person named this one, Freundlich. Now adsorption is a phenomena. Now isotherm means at constant temperature. At constant temperature. If temperature is constant, something has to be variable, right? So that is at various pressure. At various pressure. So that's where we have the Freundlich adsorption isotherm. I will plot a graph, then you will understand. For example, I have a graph where x by m is on the y-axis. Y-axis value will be decided by x by m. Now what do you mean by x by m? X is nothing but amount of adsorbate or mass of adsorbate. Okay. Now m means amount of adsorbent. Amount of adsorbent or mass of adsorbent. All of you can see whatever I am writing on the board. So that's where x by m. What is mean by x? X is amount of adsorbate. M is mass or amount of adsorbent. So this ratio talks about amount of adsorbate getting adsorbed to adsorbent. Once again I will repeat. This x by m talks about, or the x by m value tells about amount of adsorbate getting adsorbed to adsorbent. Fine. So in that way, if you have understood x by m term, now I have a question. If x by m value is getting increased, if x by m value is getting increased, what it indicates? Once again I will tell. If you have understood this one, it's very good. For your competitive exams, it may help you out. So when it comes to x by m, where x is amount of adsorbate or mass of adsorbate involved in the process. Now m means amount or mass of adsorbent used in the process or involved in the process. So that's where we have the x by m value. Right? Now in that case, if x by m value is getting increased, what it indicates? Now Nishchita, she has told adsorbate is more. Fine, that is true. Because x is in the numerator, which is related to adsorbate. That means adsorbate is more. That is fine. What else?
It's a good absorbent.
Very good. Another point here. So with respect to that particular adsorbent, it's a very good adsorbent because even at less amount, it is taking more amount of adsorbate. Try to understand. Here Mayank is telling that this indicates that it is a very good adsorbent. Yes, true, because even at less amount of adsorbent, it is containing more amount of adsorbate. So don't get confused. If you are not understanding what I am telling, you can ask me the question. I am ready to explain it once again. Now, as the m value increases, x by m value is going to decrease. As the x value increases, x by m value is going to increase. Whether I am clear? Once again I will repeat. As the m value is decrease, as the m value will decrease, x by m value is going to increase because m is in the denominator. As the x value increases, naturally x by m value will increase because x is in the numerator. Now we will go in opposite word. As the value of m is going to increase, x by m value is going to decrease. As there is a decrease in the x value, x by m value is going to once again decrease. So that means x by m value will talk about or it tells about efficiency of adsorbate and adsorbent, suitability of adsorbate and adsorbent, whatever combination we have taken, whether they are good combination of adsorbate and adsorbent. That's what x by m value will tell. Fine. So that's on the y-axis. Now when it comes to x-axis, it is related to pressure. It is related to pressure. That's where I have the x-axis. Since I am dealing with gaseous molecules as a adsorbate, therefore this graph is applicable. I will repeat. Here adsorbate is a gas. Adsorbate is a gas. So by using that particular example, I have applied on the x-axis as the pressure and on the y-axis as x by m. Whether all of you have understood? Any doubts in this regard? Okay? So in that way, I am going to have the curve like this. As there is in textbook, same way I am writing. Because when I am talking about gaseous molecules, it will be expressed in terms of partial pressure. Its concentration will be expressed in terms of partial pressure. So these are the x by m value at different pressure. Right? So as the pressure increases, value is going to increase. Value is going to increase. Now why we are getting three graphs? Because it has been done at three different temperatures, that is T1, T2 and T3. What are T1, T2, T3? T1, T2, T3 are the temperature. T1, T2 and T3 are the temperatures. So T1 is the one particular temperature at various pressure. This is the graph. At T2 as the one temperature at various pressure. This is the graph. At T3 at another temperature at various pressure. This is the graph. Therefore it is called as isotherm. So at T1 at a different temperature, this is the value, isotherm. At T2 at different pressure, this is the graph, isotherm. At T3, once again constant temperature is maintained but pressure was variable, so therefore it is called as isotherm. Right? Now you should tell me what is that relation between T1, T2, T3? By considering we are dealing with the Physisorption. Please remember, if you are not understanding, I am ready to explain it once again. Right? Now, whatever graph is there, my question here is, if we are dealing with Physisorption, now what is the relation between T1, T2, T3 with respect to their values? Whether T1 is the greatest value or T3 should be the highest value. Among these three, which is highest value? Whether T1, T2 or T3. Okay, decrease in Physisorption, fine. My question is not that one. My question is, to be simple, yes, there will be three temperature with different values we have taken at three different temperature. Now, what is T1? T1 is more. Many people are writing T1 is more. Very good. We can tell that T1 is greater than T2. T2 is greater than T3. Right? So T1 is greater than T2, T2 is greater than T3. Therefore, based on the graph, we can clearly tell that as there is an increase in the temperature, amount of adsorption is less. As there is a decrease in the temperature, adsorption is getting increased. Once again, decrease in the temperature, adsorption is much more higher. Right? So that's where we can tell that increase in the temperature decreases the x by m value. Decreases the x by m value. So therefore, as there is an increase in the temperature, decreases adsorption, that is Physisorption. Decreases Physisorption. This is what the conclusion which we can draw from this particular graph. This is what we can draw from this particular graph. All of you are understanding? Any doubts? It may be important for your competitive exams. Please remember. And for board you can expect 1 mark. Which will be that one, I will let you know. But for time being, have you understood? So that's where Freundlich adsorption isotherm talks about. Any doubt? So now based on this we have an equation, or this graph is based on the equation where x by m is equal to k p to the power of 1 by n. Kp to the power of 1 by n. Okay. So one point is very clear, where n value should be greater than 1. Where n value should be greater than 1. Now x by m and p, already I have told what are those. Now k and n are the constants. K and n are the constants whose value is going to be decided by adsorbate. Whose value is going to decided by the adsorbate and the adsorbent. So that's where k and n value will be decided. These are decided by adsorbate and adsorbent. Nature of the adsorbate and adsorbent. Constant decided by nature of adsorbent and adsorbate. So that's where we have the k and n value. Okay. So that's where we have the k and n value. You have to remember this equation. Why? I will tell you. You have to remember this equation. All of you have understood? So that's where I have got the non-linear curve. It's not a linear curve, right? So that's where we have the Freundlich adsorption isotherm. Any doubts? So if you have understood this one, further same graph, I will write it in a different way. Same graph, I will write it in a different way. Okay. Now, what I will do is apply the logarithmic form for this particular equation. I will apply the log rule for this particular equation. Now I will write that log of x by m. Log of x by m is equal to kp to the power of 1 by n can be written as log of k plus 1 by n into log of p. All of you will agree? So this is the equation which I am going to get from here. Therefore, I asked you people to remember this equation. Right? So that's where we have the equation. Now, what is the advantage of this equation compared to this? Although it is derived from here only. So this is Freundlich adsorption isotherm equation. It is derived from the same. So what is the difference between these two?
It's a straight line. Y is equal to
Very good. So it's going to give the straight line because it's a straight line equation. Y is equal to c plus mx. C plus mx. Right? Now we are going to get the straight line. I will plot a graph where x-axis will be, y-axis will be log of x by m. Right? Y-axis will be log of x by m. X-axis will be, what is x here? Log of p. So that's what I am writing here. Log of p as on the x-axis. Now, what is n? What is m here? M is nothing but slope. What is that slope? 1 by n. What is c? C is nothing but intersect on the y-axis. That is log of k. Since I am having positive, so positive slope value, the graph should be straight line should be like this. It cannot pass through the origin. If it is passing through the origin, this equation would have been log of x by n 0 plus 1 by n into log of p. Here it is not 0. Here it is log of k. So it should not pass through the origin. Okay. So now, where this line is going to intersect on the y-axis, that is nothing but log of k and the slope of this one is nothing but 1 by n. Slope of this one is nothing but 1 by n. That's where I have got the equation, modified equation. Freundlich adsorption isotherm straight line equation. So based on this particular graph, now we can find out what is the n value and what is the k value for that particular adsorbate and adsorbent. That's where this graph will have the application. What is that application? It talks about the nature of adsorbent and adsorbate. Now Ravikant is having a question. What will happen if n value is equal to 0? Yes. Now naturally when n value is equal to 0, right? Now log of k will be there, intersect will be there, so it will become like this, straight line, parallel line it will become. Log of x by m, log of p, yes Ravikant, where n is equal to 0. That indicates that pressure does not have any impact on the adsorption. Or I can tell that when n value is becoming 0, adsorption is independent. Very good question. Independent of pressure. Independent of pressure when n value is equal to 0.
So slope should come like this, right? If n is equal to 0. Slope will come in straight line, like this.
No, here also there is no slope.
So slope is 1 by n. So slope is infinity if n is 0.
Like this we cannot get because p is here, no? We have to find the relation
It won't have
between log of, okay. So Mayank's question here is whether we can get this straight line like this. So I am not talking about this one because independent of pressure means x by m value should not change. If that this particular pressure only it is applicable if I am getting straight line like this. So if I am changing the pressure, when there is a change in pressure at one particular point I cannot talk about. So I have to talk about variable pressures where pressure value is getting changed. If I am getting straight line like this, only at one particular pressure I am putting the graph. So therefore this should be applicable. Anyway, I will confirm it. I think this should be applicable because this indicates that although there is an increase in the pressure, there is no change in the x by m value. It is constant. Throughout the various pressure it is becoming constant. That means adsorption and pressure they have become independent of each other. They are not dependent. They have become independent of each other. Now since he has used n is equal to 0, I will make a statement here that n value should be 0 to 1. Always you will get the n value as 0 to 1. Okay. So n value will be 0 to 1. Now if n value is equal to 0, this is the scenario. If n value is equal to 1, then what will happen? If n value is equal to 1, so if n value is equal to 1, what will happen? You can tell me. If n value is equal to 1, that means 1 by n value is equal to 1. That means n value is equal to 1. What will happen? They are getting video, right? All of you can see me? No one is replying. Yes. Yes, sir. Yes. Okay. Now, Ravikant, your doubt is clear? You had asked n is equal to 0. N is equal to 0, this should be the case. This should be the graph we are going to expect. Okay, na? because pressure and adsorption will become independent of each other. Now my question here is, because n value can be 0 to 1, n value can be 0 to 1. Now my question here is, if n is equal to 1, that is 1 by n value is equal to 1, what it indicates? Okay, Varshita, she has written, very good. So adsorption varies directly with pressure. How will be the graph then? Huh? So graph will be like this, almost like this, x by m and pressure, where graph will be like this when 1 by n value is equal to 1. Right? So this is where 1 by n value is equal to 0. Here it is 1 by n value is equal to 1. So that means adsorption is directly related to, under this condition, adsorption is directly related to pressure. Adsorption is directly related to pressure or proportional to pressure. Yes, very good, Gurumurti. Means Brinda. Fine. So that's where we have got the 3 different graphs. So this is graph for this particular general equation. This is for specific condition. This is also under specific condition. Which is that specific condition? When 1 by n value is equal to 1, this graph, where adsorption will be directly proportional to the pressure, and this is the condition where 1 by n value is equal to 0, where adsorption will become independent of the pressure. Any doubts? With regard to this one, any doubts? Now whatever I have written, this is applicable for, whatever I have written, it is applicable for gaseous molecules, because we are dealing with pressure. Now Nishchita, no sir, that means whether you have any doubt, Nishchita, whether you have any doubt, you have written no sir. If you have doubts, you can ask, so that I can move further. I can clear that doubt and I can move further. Any doubt, Nishchita? So anyway, once again I will explain. So this is the graph. Based on that, this is the equation. Based on that, we have got this graph. This is the general form or general graph for the Freundlich adsorption isotherm equation, where that equation has been modified to logarithmic form. Right? So log of x by m is equal to log of k plus 1 by n into log of p. Now where x-axis will be log of p, as you move towards the rightward direction, naturally p value is going to increase because you are moving away from the 0. Right? Now same logic for x by n. As you move upward direction, you are moving away from 0. That means adsorption rate is going to get increased as you move upward direction. Now this is standard graph where slope will be equal to 1 by n and intersect on the y-axis will be log of k. Right? Now I have one particular rule or condition that n value be between 0 to 1 or 0 and 1. So that's where we have the n value. Now if that is the case, if n value is equal to 0, if n value will be equal to 0, that means the whole thing will become 0 here. So that means log of x by m will be equal to log of k. That is only left over. Right? So in that way, the graph will be like this, because log of k value we are getting, but there is no change in the x by m value. Right? So therefore, they will become independent of the pressure. Amount of adsorption will be independent of the pressure. So that's what this parallel line indicates. For example, if the pressure here it is 10 Pascal, here it is 20. Simply I am giving the values, and here it is 40. Now at 10 also same x by m value, at 20 also same x by m value, at 40 also same x by m value. That indicates that adsorption is independent of the pressure. Okay, so that's what we can conclude here. Now when I am talking about this one, when 1 by n value is equal to 1, another condition. So now in that case, n value is at higher value, that is 1. So 1 by n value is equal to 1 means we are going to get the graph like this, where adsorption is directly proportional to pressure. That means if I am doubling the pressure, even x by m value will get doubled. So further increase in the pressure, same amount of x by m value will also get increase. Got my point? So that's what directly proportional to indicates. But here that is not the case. Although there is increase in the pressure, same way x by m is not getting increased. It is increasing, but not in the same way. Therefore, that is directly proportional to the pressure. Any doubts? Okay. So whether I am clear, or if people have still any doubts? All of you can see me. Okay. So that's where we have the condition. Okay. So shall I move to the next one? If you don't have any doubts, I can move to the next one. So now whatever I have written or whatever we have discussed, it is important for your board exam, 1 mark question you can expect, and for competitive exam also it is bit important. That is Freundlich, adsorption, isotherm. In the board exam, question can be in such a way that, as we have discussed, that is related to n value. So draw the graph when n is equal to 0, or when n is equal to 1, or when n is equal to 0.9. Like that questions will be there. Then you should give the graph. Or they can simply ask, write the Freundlich adsorption isotherm equation. Then better you can go with x by m instead of log of x by m. You can go with x by m is equal to kp to the power of 1 by n. If you write logarithmic equation, fine. But if you remember this one, better to go with this. Okay? Whether I am clear? That's how the question can be asked for 1 mark. Now, same equation can be written. Same equation can be written if I am dealing with the solution. Adsorption, where instead of gaseous condition, we have the liquid and solids. Right? So in that case, I have to go with the C, concentration. Whatever P is there, replace that one with the C. X by m is equal to Kp, Kc to the power of 1 by n. Same thing. Now, here log of x by m is equal to log of k plus 1 by n log of C. What is C here? C is concentration. C is nothing but concentration. Instead of P, we have to deal with the concentration, because we are talking about the adsorption where solid molecules and with liquids. That is concentration. So that's where we have the modified equation. That's all. There is no other changes. Okay, na? So that's where we have the Freundlich adsorption isotherm. Okay. So any doubts up to here? Any doubts if people have? Okay. So what you can do is, while coming tomorrow, it's very simple questions are there. You can go through in-text question. You can go through in-text question, whatever they have given. And another thing here is, you should be thorough with Physisorption, chemisorption and Freundlich adsorption isotherm. So while coming tomorrow, you should be thorough with these three concepts, or I can make it as two. That is difference between Physisorption and chemisorption, and another one is related to Freundlich adsorption isotherm. So along with that, go through in text question. Very simple questions are there. Okay. So anyway, I will stop here. We will meet tomorrow. Right? Today Prime Minister's speech was there, and it has been extended to May 3rd. Lockdown has been extended to May 3rd. So don't go outside. Try to focus on the live class, or you can watch the video. Fine. Take care. Okay.